Inside the cabinet here, where we are making the high concentration of oxygen to inject into the water and also the ozone, it begins here. There's a small oilless compressor. We're just pulling in ambient air and compressing it. We run it through a cooler to try to extract as much water as we can out of that air supply, because eventually we're going to be feeding it into this oxygen concentrator. We want as dry of air as possible. That compressed air goes through a little radiator, cools it down. There's two coalescing filters that squeeze as much moisture as possible out of this air. From here it's fed into the oxygen concentrator. Now, an oxygen concentrator simply takes the ambient air and pushes it through a sieve material to remove the nitrogen, and you're left with 93% oxygen. Cycles back and forth as one sieve gets filled with nitrogen, cycles to the other, and vents the nitrogen out of this port on the top here. So once we have the oxygen, that oxygen is fed through an ozone generator. This one has ozone generator mounted here on the bottom. As the oxygen flows through it, high frequency, high voltage is applied to a small gap where that oxygen is fed through, and a certain percentage of it is converted to ozone, which is really just a high energy form of oxygen. It's in 3 molecules of oxygen, O3. So once it goes through this, it's oxygen plus the ozone. The ozone then flows through this ozone-resistant tubing and exits the cabinet through this port on the bottom. We do have a motorized valve here, ball valve to shut off the ozone anytime that the compressor is not running. That prevents any water from coming back when the machine's not running, so it's one of the safety measures to keep water out of the ozone cell. From here, the ozone flows out. Also, a couple features inside of here. We do have a leak sensor for the ozone gas. In the event that any leak develops in here with ozone, that sensor will turn off the ozone generator. The rest of the system will continue to run, and on the front there will be an indicator that it's experiencing an ozone leak. When the ozone clears out, it turns back on, but it needs attention. It needs to be repaired for the machine to operate properly. Also on the front here, we've got a system on switch. When this is turned on, everything will operate except for the ozone generator. So you turn this on and it'll be making oxygen, injecting oxygen into your system, and it could be run even without the ozone generator, but your oxygen levels will not get as high as they can with the ozone added. The next switch here will turn on the ozone. Typically, after everything is operating properly, you turn on the ozone. We've got a gauge here that's measuring ORP, that's oxidation reduction potential. It's a sensor shortly after the ozone generator that's used to control the ozone generator. You can set the levels, and when it reaches a certain level, it'll turn the ozone generator on and off. If it's set really high, then it'll just continue to make ozone all the time. The dial here is an ozone output adjust. You can turn that from down to 0 up to 100% ozone production. These two lights up here, depending on what your settings are with that ORP, when it reaches the high set point, this light will come on telling you it's reached the high set point, and that's why it's turned off the ozone generator. The other light is a low ORP. You can set that point, and this light will come on when it reaches the bottom level. Remaining two gauges here are simply controls for flowing the oxygen. We have a pressure regulator and a flow meter that is going to show you how much oxygen is flowing from your oxygen concentrator into the water. Down here is one more warning indicator. If your oxygen purity that's being generated falls below 83 or 85%, then this light will go on. Typically, that will only come on if it's flowing too fast for the oxygen concentrator to keep up, or there are some problems either with the compressor. It could be a lot of different things leading to your concentrator just not working correctly, and those need to be addressed. Okay, a few items for maintenance purposes. Right at the beginning here with the air compressor, it's pulling ambient air in. There's a little air filter here that's just filtering out the air before it goes into the air compressor, and depends on the air quality conditions. If it's really clean, it might go for it could go for 6 months, but I would say at least every 6 months that filter ought to be changed. From there, it goes to these coalescing filters. These also are replaceable. You just take the cap off the bottom. These filters are screwed out. They can be purchased on our web store. There's two different ones. When it goes to first, this is a higher micron. It's a one, I believe the first one is a 0.5 micron, and then the smaller one is a 0.1 micron filter. At the top here is a pressure gauge, mainly for diagnostics. For your air pressure coming in, you want to keep that around 20 to 30 psi. The oxygen concentrator depends a lot on what type of air conditions you have. These can last for years with really good quality air, but typically once a year it should really be assessed what the performance is, or if you're starting to see low purity, you may need to replace the sieve beds on your oxygen concentrator. This air compressor is about 8,000 hours before you need to replace there's a rebuild kit that can be used with this air compressor. This check valve is also a point of maintenance. They can get sticky. They can be opened up and repaired, or you just need to replace it if your flow is not going through it, or if it's not preventing the water from going back into your system. There's also another little check valve here. This one is fairly easy to replace. You have to cut the tubing on either side of it and replace that check valve periodically as well, about at least every 4 months or so if it's running continuously. In this flow sensor, there is a membrane in here and electrolyte. With each system, there's a little kit for some replacement parts, but this pulls out, and this membrane can be replaced. This cap, this whole component on top here threads off, and it's like you've got a cup here. You take when you remove this top cover, there is a membrane on here that can be replaced. When it's screwed back down, inside here is where you put the replacement electrolyte. That's poured in there, filled up to the top. Screw it on really slowly. You do want to open up this vent here so that it doesn't build up pressure. And slide it back in. And you're good to go. There's an ORP sensor back here. This is measuring your oxidation reduction potential. From time to time, that sensor may need to be replaced. That sensor is reading up in the top here. So that covers the main features and maintenance of this water injection system. If you have any other questions, we've got a lot of information on our website, and feel free to call.